your time and joining the ninth episode of AWS Mainframe Modernization Broadcasting Channel. Thank you for your active participation since beginning of this year, and we have been adding new sessions. So please stay tuned for the next set of sessions, which are going to be added post the New York Summit, which is happening on June 17th. So in our today's webinar, we are going to discuss breaking data silos, moving mainframe data to Snowflake for enterprise-wide analytics. And the webinar is primarily going to be delivered by our ISV partner Treehouse. So Treehouse has been serving enterprise customers close to 4 decades now, providing solutions for real-time data replication between variety of mainframe and non-mainframe data sources. I'm Sunil Divila and I'm a worldwide mainframe modernization solutions architect based out of Atlanta, Georgia. And along with me, I have Ellie from Treehouse. So Ellie, would you like to introduce yourself?
Yes, hi everyone. My name is Ellie Savova, and I work at Treehouse Software, focusing on developing cloud-native SaaS solutions as a cloud solutions architect for large enterprise data migrations. And I work very closely with our customers throughout their product implementations. We'll begin with a brief introduction of Treehouse Software, and then we'll dive into today's customer case study right away. We'll look at the challenges that the enterprise faced, their modernization strategy, and the solution we were able to provide for them. From there, we'll walk through how the solution works, how data moves from the mainframe into the target platform, its value, and how the architecture is deployed all on AWS. Finally, we'll review the business outcomes and finish up with a demo. As Sunil mentioned, please feel free to submit any questions as you go. My colleagues will be answering most of them in the chat. We'll also leave some more time at the end for Q&A to address everything in more detail. With that, let me start by introducing Treehouse. So Treehouse has been helping customers move and integrate data since 1982. We started out by developing mainframe tools, and then in the mid-90s, Treehouse further evolved into mainframe to RDBMS replication. Then by the early 2000s, we had expanded into cloud data replication. That evolution brings us to where we are today, supporting both mainframe and non-mainframe data sources across modern cloud environments. We work with organizations across a very wide range of industries, including banking, finance, telecommunications. We have a good presence in the government sector as well, transportation, and many others. One thing we've learned over the years is that regardless of the industry, enterprises eventually face the similar challenge, which is critical business data becomes siloed across legacy systems, just as Sunil mentioned, making it difficult to use effectively. For our customer in question, though, this data silos was what ultimately led them to begin their modernization journey with us. Now let's meet the customer. Who is this we're going to be looking at? The organization we'll be discussing is a large auto manufacturer with critical business processes all running on 3 mainframe systems. So they were looking at Database, vSAM, and DB2. Over time, these systems became home to a significant amount of business critical information, supporting their daily operations across their entire enterprise. At the same time, the auto manufacturer had already invested in Snowflake as its strategic target and wanted a way to bring that mainframe data, all 3 sources, into their broader ecosystem. The goal was very straightforward: make this mainframe data more centrally accessible to the business and provide a foundation for future initiatives. On paper, this sounded simple enough, but as we'll see next, achieving this goal proved to be much more challenging than they had originally expected. The auto manufacturer had already tried solving the problem on their own. They faced that build versus buy conundrum and let's see if we can build it before we try to buy something. They built mechanisms to move some bits of mainframe data into Snowflake, but the approach just never scaled and it wasn't up to the level that they needed for their large enterprise. A small trickle of data would eventually make its way across to their target platform of Snowflake, but it took 2-3 days, required hours of manual effort every single time, reformatting the data. It just wasn't a reliable enough method for this enterprise. The business users still had to go back to the mainframe whenever they needed the most current information. They didn't know if what they had coming in was current. It just wasn't complete. The reporting teams, they were working with stale data, and the analytics team struggled to get the complete view of the business because that data delay from the different systems, it wasn't something workable. After investing significant time and effort into their own mini modernization project, it became very clear that they needed a scalable, automated way to continuously move data from these three AWS, vSAM, and DB2 sources to Snowflake. Now, to understand the gap they were trying to close, let's take a look at their broader migration initiative because it's not just these three databases. The organization was already consolidating data from many different systems across the business into Snowflake. Their Oracle databases were getting into Snowflake, SAP data, factory, IoT devices, everything was now in Snowflake, but the missing pieces were those from the mainframe. They're really hard to get to. Without their AWS, vSAM, and DB2, they could never achieve the complete data consolidation initiative they were looking for in Snowflake. But why go to Snowflake in the first place? The reason Snowflake became such an important part of this initiative was because they had already picked that as the company's strategic platform for the future. Business users wanted a modern, easy to use, centralized console where they could quickly combine the findings across all the other systems into one. Great idea, right? They sought to eliminate having to go to 10 different places and manage 10 different logins for each system. A lot of us know how that can be. The data modelers also needed everything in Snowflake. They had built all these trend analyses, formulas, and queries, but then they were stuck piecing the data together themselves, which they spent more time on than actually doing analytics. And how is that efficient? Oh, and the leadership. Looking ahead at how machine learning models and AI were becoming way more and more current and practical, realizing that those tools were powerless until they were reliably connected to data sources all in one place, namely Snowflake, that provided all these capabilities. The challenge was establishing a reliable way to continuously move data from AWS, vSAM, and DB2 into Snowflake. And that's where we come in with Treehouse and our TDT offering, which was able to continuously move data from the three AWS, vSAM, and DB2 sources on the mainframe into Snowflake at scale. Now, TDT provides both bulk load and change data capture capabilities out of the box, which meant they could not only bring existing mainframe data into Snowflake, but they could also continuously capture the changes in near real time, which was the biggest thing for our auto manufacturer. Instead of spending months and years building infrastructure trying to, they could focus more energy and time just consuming the data, working with it. So TDT went in nicely. So what is TDT? This tongue twister. TDT is short for the Treehouse Data Flow Toolkit. It's an AWS native microservices application designed specifically for moving data into modern analytics platforms. TDT supports targets such as Snowflake, Amazon Athena, Amazon Redshift, and others. Most importantly, it is delivered as a pre-architected and pre-configured solution. So what that means is customers don't need to build any part of the framework themselves. The automatic creation of the framework in AWS is part of the solution. TDT doesn't just move the data, it also creates and manages the Snowflake resources required to consume that data effectively. Before data can be loaded into Snowflake, before you can do anything, someone has to create the target proprietary resources. And those would be the schemas, the stages, the file formats. These are all proprietary to Snowflake. But then we have the tables and the views, those empty tables and views that you need to then populate once you do your loads. Thankfully, TDT automates this entire part of the process. Once those resources are in place, then TDT performs the initial bulk load and then continuously processes CDC events as changes occur on the mainframe. The two most important resources created by TDT, I'd say, are the delta tables and the views. It's what we're going to be physically looking at the most. Let's start with the delta tables. So every single insert, update, delete that's captured from the mainframe is accumulated in these delta tables. Rather than only maintaining the latest version of a record, TDT continuously preserves the history of changes here over time. So these delta tables are designed to, you set them up at the beginning of your implementation and you keep them forever and ever. They hold all of that history. And at Treehouse, we often say history is gold because over time, these delta tables become a growing analytical asset because they're essentially a log of all the transactions that happened on the mainframe since you set up your pipeline. Your analytics teams typically consume exactly from these delta tables because they want access to the complete history of how the business evolved over time. Analytics is all about time. The earlier you start capturing it, the more valuable it is. On top of these delta tables, however, TDT automatically creates views. This is a functionality in Snowflake. You can create a view on top of a table. These views represent the current snapshot of the business and are continually refreshed as the changes arrive from the mainframe. So the delta table will hold everything. The view will just show you the current snapshot. Now, business users, different from your analytics teams, right? Your business users generally don't really care about history and analytics. They simply want the current state of the business to do their reporting, to do their daily business initiatives. That's why they typically just consume the views. TDT just provides both audiences with exactly what they need from the same data pipeline. You don't have to create multiple pipelines. It's an all-in-one solution. Current state business views for reporting, and then you have the complete historical data for analytics. And that's one of the reasons this solution has been so successful for our auto manufacturer in question. In Snowflake, they have an even greater flexibility, and they've defined even more views on top of these views that we see here. But that is just something to play around with once you get the product and you uh, fit it to your needs. But these are the basic ones they utilize the most. Now let's look at what the architecture actually looks like of TDT. One important thing to note is that TDT doesn't go directly after the mainframe by itself. So instead, it works alongside a mainframe data replication tool that captures the changes happening in the source mainframe. And then customers can use different tools here. So you can have any replication tool. In this implementation, the auto manufacturer used Rocket's RDRS tool, but you can substitute this with anything that you already have, right? The mainframe replication tool captures the changes occurring on the mainframe and publishes them to a data streaming platform. This is also a substitutable component. They chose Amazon MSK Kafka as their streaming platform, but it can be, yeah, it can be anything. It could be Amazon Kinesis data streams, for example, or any other flavor of Kafka. There are so many. Now, TDT processing kicks in right after mainframe to streaming platform connection is in place. So as soon as the data arrives in this Kafka topic, and all this is near real time or real time, TDT then takes it the rest of the way into Snowflake. TDT is built as a serverless microservices application, which allows different parts of the framework to scale independently as work demands change. Part of the reason it's built on AWS, leverage the cloud. Earlier, we talked about the delta tables and views. Here you can see where those resources fit into the overall architecture. One of the first things TDT does when new data comes in from the mainframe is to automatically create all the Snowflake resources required for the data transfer. Looking through the metadata, creating structures where it can land. That includes the schemas, the stages, the file formats, which are proprietary to Snowflake. And then you have those delta tables we talked about and the various views. It creates JSON views and user views. The JSON views are just the data in JSON format in case you want to do some pandas or PySpark manipulations with it. And then you have your user views, which are relational alike. So if you want a view of your mainframe as it looks like on your mainframe, you'd want to utilize that kind of view. The customer never creates anything in the target manually. At least they don't need to. You can leverage it as it is. Of course you can, but TDT provides and runs the scripts automatically, eliminating the possibility for human error when you're creating everything, for example, in a bulk load. So you're doing a large bulk load into Snowflake. TDT creates automatically all the target creation and then the load, which is why you're using it in the first place. As data begins flowing from the mainframe, TDT populates the delta tables and then continually accumulates the history of all the inserts, the updates, the deletes over time. On top of these delta tables, the views are created as we had discussed. Now, at this point, we've talked about what TDT does and how it does it. Now let's talk about why deploying TDT on AWS provides so much value for our customers. First of all, customers get a full pre-configured framework that can be deployed in their own AWS environment in about 30 minutes. Great. Not only is this secure, but data is not leaving their territory. And second, the whole approach is inherently immutable because Lambda layers themselves are inherently immutable. They're versioned and it prevents anyone from changing the code of the application in any way. Instead of spending months designing infrastructure, provisioning services, writing code, building and deploying processes, the customer or anyone is able to start with a framework that's already built and tested. Another major advantage is scalability. Because TDT is built on managed AWS services, the platform can scale as data volumes grow without customers having to redesign the architecture. The solution is also highly available by design. There are no application servers for customers to maintain, patch, monitor, or replace. Data is also protected through the process. TDT also leverages S3 for durable storage and backup, providing that additional layer of protection throughout your pipeline. From a cost perspective, customers benefit from AWS's pay as you go model. So you're only paying for the resources you're consuming rather than maintaining infrastructure is sitting idly most of the time. And finally, customers don't need to become experts in every AWS service used by the framework. TDT abstracts away much of that complexity while still following AWS best practices underneath. The result is a solution that is fast to deploy, easy to operate, highly scalable, and ready to support future growth without requiring customers to continuously reinvent the architecture every couple years. At the end of the day, none of the architecture matters unless it delivers results, right? So for this auto manufacturer, the outcome was fully automated, of a fully automated solution capable of continuously moving data from the mainframe into Snowflake in that near real time. Today, CDC events are propagated continuously, giving their business access to much fresher data than they had before. On the bulk load side, we're talking about moving terabytes of mainframe data into Snowflake in a matter of hours. To give you a perspective of something smaller, how long it would take, we can see an example transfer of this popularly known mouse genome database. This is just a sample database with 375 million rows, 170 tables, 66 gigabytes. The transfer to Snowflake from mainframe all the way to the end is an under 5 minute transfer. Now, this transfer will vary in time because you do have those two components. You have the TDT component, but before that, you have that mainframe data replication tool. And what we've seen with our stress testing is that usually the mainframe data replication tool is the one that's the bottleneck. So depending on what tool you choose, how fast it is, TDT usually runs much faster than that first bit. So it is how you make it. Um, could it be made even faster? This whole thing? Absolutely. If a customer wanted to spin up a larger Snowflake warehouse, increase concurrency thresholds there, or also in AWS, and allocate more resources across the entire environment, they could drive the latency down even further. But doing that comes at a cost. One of the things we like about this architecture is that the customers are able to fine tune and balance everything themselves. Every organization has different requirements. Some businesses need data available within seconds. Others are perfectly happy with minutes or hours if it means significantly lower operating costs. And the framework gives customers the flexibility to choose where they want to sit on that spectrum of cost. So for our customer, the current configuration provided, like the default one and with slight tweaks, provided the right balance between performance and cost. They were happy with getting their huge bulk loads there in several hours. Beyond performance, they gained capabilities they simply didn't have before. History accumulation became automatic. Mainframe hierarchies were preserved in the target. We'll talk about the hierarchies in our demo. The architecture could scale as data volumes continued to grow without requiring the redesign. Now, on the business side, they were avoiding those months and years of engineering and custom framework configuration. Keep in mind, they had already lost some time trying to engineer it themselves. They accelerated their entire modernization initiative, gave the business users full access to the data, and established a foundation for future analytics, AI, and machine learning because everything was already in Snowflake. Most importantly, they now have a repeatable framework that can continue evolving as their business grows. And hey, if you want to ditch Snowflake and go target a different analytics platform next year, that switch can be a seamless transition because AWS is an intermediary in the whole thing. They could just point TDT in a new direction. The auto manufacturer in today's case study happened to be working with AWS, vSAM, and DB2. However, TDT supports a wide range of other mainframe technologies, including IMS, IDMS, Datacom, flat files, and several others. Other TDT flavors are designed to source from non mainframe sources as well. We're not going to get into those today. And the targets list is not just Snowflake. You can go to Amazon Redshift, Amazon Athena, RDS, even Bedrock SageMaker. Um, yeah, this is to give you some more perspective. Just wrap everything up and talk about our takeaways. If there's one thing I'd like you to remember, it's that a successful data modernization isn't just about moving data, it's about using a framework that can scale and adapts to the environment. Data centralization is key to an efficient business. Historical data retention enables analytics, and together they create a foundation for future innovation. And that's exactly what TDT helps organizations achieve, transforming mainframe data into a strategically utilized asset. Thank you for joining us today. If you'd like to learn more about TDT or discuss your own modernization initiatives, I encourage you to reach out to us directly. Feel free to email Joe. His email is here, jbrady@treehouse.com. And my team and I will look forward to hearing from you about your modernization initiatives. Also, if you'll be attending the AWS Summit in Washington, D.C. on June 30th and July 1st, it's a 2-day event. It's free. Be sure to stop by and say hello. I'll be there.